This is going to be a discussion on finding the area bounded by two curves. Back in chapter 5, what we did is we used the definite integral to find the area bounded by a curve. So suppose we have some curve f of x. What we did here is we found the area, say, bounded by the curve, above the x-axis, below the curve, and between two lines. So we might have something like this. Between A and B, we were going to find this area right here, the area of that region. So we're going to make this a little bit more general now. What we're going to do is not just have the x-axis there, but what we want to do is maybe we have another curve here, g of x. And now what we want to do is find the area of the region bounded by these two curves, say between A and B. So we're looking for this area right here. Now in chapter 5, when we were finding the area bounded by the curve in the x-axis, we had this as an integral of from A to B of f of x dx, where this dx, remember, that was the length of the base, and the f of x, this was the height of the rectangle. So remember what we did here. We had a curve and we put in these rectangles, and by getting the area of that rectangle and then adding them up and then letting the number of rectangles go to infinity, we got the area under the curve. Well, the difference here is now this. If you look at this rectangle and the height of the rectangle does not go from the curve down to the x-axis, which actually we could write like this, right? The height would be the f of x, that value, minus that value. So we just get f of x. But now when we have two curves, say here's our f curve and then here's our g curve, the height of the rectangle is going to be, all right, it's the top, which is f, and the bottom, which is g. So what we're looking at here for the height of the rectangle is f of x minus g of x. So this idea is going to bring us to this definition here now, not definition, but this formula here for finding the area bounded by two curves. So let's suppose that f of x and g of x are both continuous functions, right? So smooth continuous curves for which f of x is greater than g of x. All right, now that's what I've drawn here. F is greater than g, right? F is bigger than g. The f curve lies above the g curve. So we've got two continuous functions. F curve lies above the g curve on some interval. Then the area bounded by these two functions and the vertical lines, here's the vertical lines over here, A and B. So I've got the f curve continuous, lying above the g curve continuous, bounded by the lines x equals a and x equals b. So this area right here, here's the formula for getting that. It's the integral from a to b of f of x minus g of x. Remember, f of x minus g of x is the height of the rectangle, and the dx, that's an infinitesimally small base of the rectangle. So let's look at an example to see how this is going to work. Let's find the area bounded by this curve here. Now notice this is a parabola, it's x squared, but it's negative, so it opens downward. And this parabola, this is an x squared, so it's a parabola, but it's positive, so it opens upward. So we want to find the area bounded by this curve here, and the lines x equals 0 and x equals 2. Now, I'm going to insert a graph of this so we can see just what it is that we're doing. So here's a picture of these two curves. So the top one is, the red one here is 9 minus x squared. You can see when x is 0, y is 9. And the bottom one is, the blue one here, is x squared plus 1. So you can see when x is 0, you get a 1 here. Now what we want to do is find the area of this region here bounded by those vertical lines, 0 and 2. Right, so we're going to go from here to here. Now, I think it's a good idea to draw in a representative rectangle. So if we draw in just some rectangle here, we'll get an idea of what it is we're looking at. So the top, all right, the upper rectangle, let's just say the top is the f of x, and the bottom here, the bottom of that rectangle, that's the g of x. So our formula, or our area formula, is going to be from 0 to 2 of f of x, I'll write everything here, f of x minus g of x dx. This will give us the integral 0 to 2 of, okay, now, f of x is 9 minus x squared minus g of x, which is x squared plus 1, all that dx. This will give us the integral 0 to 2 of, okay, let's get rid of these parentheses. We'll get 9 minus x squared again, and then minus 1 dx. How about the integral 0 to 2 of, okay, I'm going to write it negative 2x squared plus 8 dx. Now let's integrate. This is going to be negative 2x to the 3 over 3 plus 8x from 0 to 2. So let's do that up here at the top right. We'll get negative, now put in the 2. We'll get negative 2 times 2 cubed over 3 plus 8 times 2 minus, now if you put 0 in here, we'll get negative 2 times 0 cubed over 3 plus 8 times 0. All that is 0, so that's just out. So now where are we? We're at, okay, what have we got here? Let's just do this. 2 cubed is 8. Times negative 2 is negative 16 over 3. So we're looking at negative 16 over 3 plus 16. How about negative 16 over 3 plus, I'm going to write that over 3. So 3 times 16 is 48. I think we're looking at 32 over 3 square units.